Hello, my name is James Dyke. I'm the Programme Director for the new Masters in Global Sustainability Solutions, and I'm very pleased to welcome you to this Facebook Live event where I'm going to describe the main features of the programme, what it might be like to be a student on the programme, and also at the end, quite importantly, to answer your questions that you may have about the programme. So I'm going to spend about 20 or 25 minutes in a presentation mode. Now during that, if you do have any questions, then please do write them down and we will log them, and I'll make sure that I get round to every question at the end. But to begin, well, let me begin a little bit further back in space and time and try to introduce why we need this programme right now. What led us as a group of academics at the University of Exeter to produce this brand new programme? Well, I'm going to start about 250 years ago in the north of England. That place and that time saw the first real considerable concentration of manufacturing in factories, the increased rise of machines to power those mechanisms of production and also to move goods and services around, and the increased use of coal to power those machines. It was the Industrial Revolution. It rapidly spread across the rest of the United Kingdom and then Europe and now the world, so that today we live in a highly interconnected, globalized, industrialized civilization. We just take it for granted that many of the things that we buy are not manufactured in our home country, sometimes on the other side of the world. And consequently, what happens on the other side of the world can have an immediate and long-lasting effects on our daily lives. Our impacts have become so large that we have actually become a geological force, perhaps unprecedented in the 3.6 billion year history of life on Earth. Now the question is, how robust or resilient is this highly interconnected and complex system to some of the impacts that we are having? Industrialization and development has transformed humanity, but the challenge is that same process of industrialization and development threatens unpicking a great deal of what we care about. Now, there's another way of showing that process, and it's like this. There's quite a bit going on here, so I need to explain what's happening. So these different circles are different countries, and they're colour-coded according to this map up here. The size of the circle corresponds to the size of the population, so this big red circle here in Asia, well, that should come as no surprise, that's China. And I've labelled the United Kingdom here because obviously it's the most important country in the world. But at the start of the 19th century, in the year 1800, there was a case that the United Kingdom was very special. Because on this axis here, we see income per person in kind of today's inflation-adjusted prices, as little as $200 a year all the way up to beyond $40,000 a year. And on this axis here, we've got life expectancy as little as 25 years and up to 85 years. And at the start of the 19th century, the United Kingdom had pretty much the richest people in the world and had about the best life expectancy because the United Kingdom led the world into the Industrial Revolution. Now things begin to change as we start to see the years tick by here. Now you'll notice that the countries go up and down in terms of life expectancy. They see increases in income and decreases in income. Now for most of this period, the United Kingdom is still in the lead. It's not until the end of the 19th century, the start of the 20th century, when this little upstart country becomes some of the richest people or citizens and with some of the best life expectancy, because this is the United States of America. Now you'll see big impacts, for example, the First World War in terms of life expectancy. You'll see the Great Depression with its devastating impact on economies in most of the industrialized worlds. You'll see the impacts of the Second World War, the Great Leap Forward in China. But despite these kind of epochal moments in history, nothing seems to be stopping this migration of countries out from the bottom left-hand side all the way up to here. Such that when this video stops in around about 2009, you'll see that pretty much most of European countries are clustered up here, along with most of the Americas and increasingly Asia Pacific. What this means is that this cluster of countries here, average incomes can be in the order of $20,000 or $40,000, and life expectancy over on this axis all the way over here, that can be up and beyond 80 years. But there's something we need to bear in mind with this picture, and it's these dark blue circles, these countries based in sub-Saharan Africa, in which life expectancy and also income per person is not much better than what it was in the United Kingdom over 200 years ago. And the reason is, these countries just haven't undertaken as much industrialisation and development as we have. If we were to continue this video into the future, would we need to just continue to extend this axis and also the life expectancy axis? Are people going to become richer and richer, and are we going to live longer and longer lives? Well, perhaps not. And the reason is because what's been driving that process of industrialisation and development has largely been the extraction of fossil fuels. Now, we've known for at least 200 years that if you dig up coal, oil and gas and you start to burn it, you're going to release carbon dioxide into the Earth's atmosphere. And this is a nice visualisation of what's been going on in the Earth's climate. I'll start the video and explain it as I go along. These are points of latitude on the Earth's surface. So here's the South Pole, this is the equator, here's the North Pole. And these little dots you see correspond to dots on this map here. These are research stations, they're monitoring stations. They're capturing parcels of air from the Earth's atmosphere, and they're measuring how much carbon dioxide is trapped in those samples, and is plotted in terms of parts per million on this axis up here. This red circle is an important one. That's a research station at the top of an extinct volcano in Mauna Loa in Hawaii, just over there. And in 1979, it was recording, on average, 336 parts per million of carbon dioxide in the Earth's atmosphere. Now, as the years tick by here, you'll see a number of things happening. You'll see this big signal, this kind of big upwards and downwards motion. This video is called the pump handle for good reason, because it looks as if somebody is exerting a kind of pumping action on CO2, such that the CO2 in the higher latitudes, nearest toward the Arctic, is increasing and decreasing over the seasons. The reason for that is because if you look at the Earth's map here, and you imagine where the Earth's equator is, then most of the Earth's landmass is to the north of the equator. Therefore, in the Northern Hemisphere summer, when the trees grow their leaves and the flowers bloom, they suck in carbon dioxide from the Earth's atmosphere. In the autumn and in winter, when the trees drop their leaves and the vegetation dies back, they respire that carbon dioxide back. So this up and down motion of carbon dioxide is literally the Earth's biosphere breathing in and then breathing out. All things being equal, the amount that it breathes in would be the same that it breathes out. But you can see over on this chart, certainly from the late 1970s, if it goes up and down a lot, this kind of sinusoidal signal, there's a clearly increasing trend. Now, this video finishes around about 2014 or 2015, and today the amount of carbon dioxide in the Earth's atmosphere is higher than it has been for over 2.5, 2.6 million years ago. Now, that made some news recently because we can go back further in time using proxy records such as air trapped in ice cores. We can see that human species have never witnessed this amount of carbon dioxide in the Earth's atmosphere, ever. And there doesn't seem to be any trend at the moment for it to slow down. We know that this is going to cause environmental change, and we've been witnessing that change in our own lifetimes. Here's a good visualization of this. This video shows temperature anomalies, the differences in temperature between an average temperature, which is from 1950 to 1980. If you are dark blue, you're going to be about 2 degrees cooler than that average, and if you're bright red, you're going to be about 2 degrees warmer. This video starts in 1884, and because there's been a warming trend, most portions of the map are dark blue. But over time, you'll see the blue become yellow, the yellow become orange, and the orange become red, because increasing concentrations of carbon dioxide in the Earth's atmosphere traps more heat in the lower portions of the atmosphere and begins to warm the land and, importantly, the ocean. The ocean is where pretty much all the excess heat goes to. You'll notice that most of the warming has been happening in the higher latitudes, a process called Arctic amplification. People have become rightly concerned about climate change. We've been talking about it in a policy and scientific context for 30 years at least. It's only been relatively recently, with the school strike for climate or Extinction Rebellion, that the concerns over climate change are actually making the front page. But what do we do about that societal concern? Just recently, the University of Exeter declared a climate and environment and climate emergency. So here we are just 24 hours ago or so, and the University of Exeter joined some other universities and councils around the United Kingdom, including the UK Houses of Parliament, by declaring an emergency, such as our concern about what we are doing to the Earth's climate. Well, that's great, but then the question is, of course, what you do with those kind of declarations? I think it's fair to say that most people have no idea the size of the transformations that are required in order to limit global warming to no more than 2 degrees Celsius, just how fast those kind of transformations need to take place, and really how largely clueless we are about formulating those kind of solutions. And that's one of the reasons why the Global Systems Institute was developed. So this new master's program is the first educational offering from the GSI. So the GSI brings international researchers and educators together on the Streatham campus at the University of Exeter. And it has a pretty straightforward agenda, which is create transformative solutions. And I really want to emphasize the solutions. We know what the problems are. We have well-leading science on what we're doing to the climate, or in terms of biodiversity loss and other kind of sustainability challenges. What we do not have a good understanding of at all is what do we do in terms of implementing solutions. How can we transform societies such that they can be sustainable? Now, if you're thinking about the kind of sustainability and the global scale challenges that we might need, you might be thinking of technical solutions, but really, these are ultimately human problems. Climate change isn't really a science problem, it's a human problem, because humans are affecting the climate, and it's humans who have to somehow self-organise, need to cooperate in order to reduce their impacts. So yes, there's an important science component to this new master's programme, but there's also a fundamental role for the positionality, for the central purpose of humans in this planetary system. So initially, if you're interested in the master's programme, well, you can visit the holding page of the University of Exeter. I'll show more information about it shortly. But already, if you've got questions, then please do post them and I will get to them at the end. So what I'm going to do next is give you a very, very brief overview, a kind of feel of some of the core modules and the key features of the programme. So a programme, it consisted of a series of modules, and this programme is pretty special because all of the core modules are entirely new. We have an entirely new degree programme that we are producing. So I'm just going to introduce a few of them. The first one is Climate Change Science and Solution, which is going to be convened by Professor Peter Cox. Here's Peter. He's been featured a lot in the media because he's an internationally leading climate scientist. I just want to direct you to this little cool link at the bottom. So Peter was recently featured in a movie. It's called What If? It's like the sequel of the climate change film, The Age of Stupid. And this is a cool film because what they do, they imagine that humanity does avoid climate change. It does avoid dangerous climate change. What kind of a society would that look like? What sort of science was involved in that? So it imagines a parallel universe in which there is a Professor Peter Fox who works at the Climate University of Exeter. But it shows that we do have the science, and we do have the ideas of some of the solutions. But this module puts these things together, it gives you the frontiers of climate science, but it also asks you to critically evaluate what the solutions are. And those solutions might be geoengineering, they might be hard adaptation. There's still so much that we need to decide and understand about our societal and collective responses to climate change. The next module I want to briefly talk about is Blue Planet. So that's convened by Steve Simpson over in Biosciences. Here's Steve in the day job, I suppose. So he's a biologist. He was recently featured in the BBC show Blue Planet 2. He was one of their scientific advisors. And Steve's research is understanding underwater acoustic environments, how noise is used by animals and how animals are affected by noise underwater. And what Steve has done with Blue Planet is put together an integrated module which is going to look at, yes, physical oceanography, but then also how humans make sustainable livelihoods from the oceans. How can we manage those kind of concerns? It's going to feature some field trips, unfortunately not to coral reefs, maybe to local fisheries, but you'll get first-hand experience on how people extract livelihoods from the seas. The module or the programme is not just about climate change. There's a whole spectrum of impacts that humans are having, and it's important to understand a kind of a theoretical framework where we can try to make some sense out of that. So Theory for Sustainable Transitions, that's going to be convened by Catherine Butler, who's an academic over here in geography on the Streatham campus. And she's going to introduce important framing, such as this one. So this is called the planetary boundaries, and it emerged from work led by the Stockholm Resilience Centre, but also from academics here at the University of Exeter. And it imagines humans' impacts on different aspects of the Earth system. Imagine 9 kind of dimensions or ways in which we're affecting the Earth. So yes, we're impacting climate change, we're producing species loss, we're changing the land system, we're impacting on fresh water. And it imagines or visualises humans' impacts coming out from the centre of this circle. Such if you're in the green, we don't think there's any immediate cause for concern, but if we're in the red, then that's well beyond the zone of uncertainty. We think we're in a high risk. Now, many people are quite surprised when they look at this visualisation that climate change is actually only in the orange. It's kind of in the zone of uncertainty, orange or yellow, whereas the greatest concerns happen with biosphere integrity. Most people still don't understand that Earth is probably entering one of the great mass extinction events in the history of all life on Earth. You'd have to go back about maybe 50 million years to find extinction rates as high as they are. And most of that extinction rate has been happening as a consequence of land use change, deforestation, the disruption of phosphorus and nitrogen cycling, and then increasingly climate change. So what Catherine does, she introduces these framings and so allows you to make sense of the different ways that humans are interacting with the Earth system and different ways that we might be able to formulate developmental trajectories such that we do not exceed these kind of planetary boundaries. And then the last module I'll talk about is my module. So I convene a module called Global Challenges, and the purpose of this is to try to bring these very, very different, perhaps quite disparate issues together in a coherent framework. And we do that by trying to make it as applied and as practical as possible. So we run workshops and sessions, we'll have external partners present particular sustainability challenges, then you individually and then in a group respond to those challenges over the rest of teaching, and we provide training to allow you to do that. We give you consulting training or facilitation training, management training, as well as identifying gaps or areas that you need to brush on, which might be some of your statistics or other bits of theory. I mean, the programme is designed to be as inclusive as possible. In principle, any student from any programme can apply. You only need the motivation. And it's important to stress the motivation of where the programme came from, because I wanted to design and deliver a programme that really could make transformational educational experiences. It's my own concerns about climate change and other kind of environmental change which has led my research and teaching into this area. And ultimately, what the programme aspires is to empower you to become agents of change. If there's one thing I would like the programme could do, is transform you into that effective agent. And that could be if you are just finishing your undergraduate education, or perhaps you've had a long career in a particular industry, but for various reasons you've decided you want to have some kind of demonstrable impact on these sustainability challenges. Okay, I'm now going to quite quickly rattle through some of the other core modules. So we've discussed these first 4. I just want to briefly mention innovation and the science policy interface. What's that module about? Well, it will allow you to understand how is policy formulated, because whatever you may think of politicians and politics is a necessary part of a sustainability transformation. So we need to understand how is policy formulated. What's the role of science or advocacy in the formulation of policy? And you will get practical experience in working with policymakers to that effect. And then this last core module, global systems thinking, all of these are in themselves complex problems. They're all forms of what we call wicked problems, problems which don't have easy answers. And one way that we think we can make some impact in finding those solutions to those problems is through something called systems thinking. It's not mathematical, there's no maths in it, it's more conceptual, but it allows you to navigate complicated and complex problem spaces such that you can begin to formulate viable solutions. We do have some optional modules, and we also have a very large number of elective modules. The elective modules are far, far too numerous for me to list, so if you have some questions about potential elective modules, then post a question now or contact me after this Facebook Live event and I'll talk to you about the kind of electives that we have. But the optional modules we're going to launch with in September, we have essentially a sustainable agricultural, sustainable food system module. We have the 2 modules from the Exeter Business School, the response of business to climate change and what it means to undertake sustainable enterprise economies. So how do we develop businesses and corporations in the context of, let's say, the Sustainable Development Goals? And then we also have a brand new optional module. It's called Green Consultants. It's an optional module which you can take in which you'll receive training on consultancy skills so that you can actually become a trained consultant in the area of sustainability. And part of that module is that you will take a leadership position, you will mentor a group of undergraduate students. That's the talk component, and then we conclude with a 60 credit independent research project. That's got two flavours. It's got academic or internship. Academic is a kind of regular flavoured dissertation where in collaboration with your academic supervisor you formulate a research project and you do your data collection and you write that up over the summer. The internship is something that we start off with term 1 where we begin to identify opportunities for you, and in collaboration again with your academic supervisor and also me as the program director, we put in place a typically 8-week internship over the summer where you produce a dissertation but also a client brief as an output of that engagement. Some key features of how we actually do the teaching. Well, certainly there are lectures, but we want to get beyond the lectures. We want to try to situate your learning in the real world as much as possible. So we've got workshops, masterclasses, practicals, field trips. We try and mix the methods to fit the kind of subjects that we're covering. And again, it's always a focus on the engagement and the application. We want to see impact, certainly within academia, but as far as you're concerned, our real impact comes from outside of the university. If we have innovative teaching, then we also have innovative assessments. So yes, there might be the odd exam and essay, but we're producing posters, interactive infographics, online infographics. We have short films and some workshops and masterclasses on how to produce some short documentary features. We'll be writing press briefings and policy papers. That's a very, very brief overview of the programme. If at this point you've got any questions about it, then if you just visit www.exeter.ac.uk/GSS, that will take you to the programme page. There you'll get the overview, but then also the structure. If you click on that tab, that will take you down to the module level. Then you'll be able to see the module descriptors, be able to understand who will be teaching you, understand a bit more about the methods of assessment, the learning methods. But for now, I think we're going to turn over to the interactive question and answer session. So for the moment, thank you very much for your attention, and let's take some questions. So, the first question I have, they'll be shown on the laser display board just to my right. Ben asks, what is the teaching split between the lab, classroom and residential? It varies. So certainly some modules are going to have a large fieldwork component. So the Blue Planet module, for example, has got 2 fieldwork elements where we're going to go and visit a local fishery and then also be another engagement somewhere else. The innovation and the policy interface will be visiting most probably London, because an awful lot of policy and governance happens in the UK, in London, with the Houses of Parliament. In terms of the lab, there will be some labs. There are labs for the Blue Planet, some quite practical, actually wet lab activities, but there'll also be elective labs throughout the programme. One thing to try to remember is that with such a broad programme, there's going to be a very broad cohort of students. Some students will be coming from physical sciences, some might be coming from mathematics or maybe even climate dynamics. Some might be studying biology or maybe history or archaeology. So there's going to be very, very different backgrounds and experiences. So a core part of the programme is offering bespoke workshops or labs to ensure that all students have the sufficient requirement when it comes to some of the more quantitative elements. That doesn't mean we're going to savage you with statistics, but it does mean that you need to know the basics when it comes to some interpretation of data analysis, or maybe even what the scientific method is if you're not from a science background. Okay, so that's that question. The next question is, what sort of jobs do graduates get? That's from Meg. Well, in principle, you can imagine any kind of employment. One way to look at this is that the kind of transformations that society is going to undertake, and it's not a question of when, it is. We either do these transformations before the environment forces us to, or as a consequence of the environment forcing us. Either way, we will be transforming our societies. And that means all of society will be changing in some way. So already, if you go to any of the large graduate employers, you will find that they have sustainability, if not themes, then kind of positions. You just go to the website of any large corporation, they all have a sustainability tab. They all need to be mindful. Now, I'm not suggesting they do that because they're being good global citizens, although obviously some of them are, but they realise that climate change, just climate change alone, is going to be affecting their bottom dollar, and they need to understand what are the threats, where are the pressures, where are the risks, and then how they, as an organisation, can respond. So there's certainly going to be opportunities in that private corporate sector. But then we would also expect our graduates to be working in government, national government, local government, non-governmental organisations, volunteer sector, pretty much any kind of area that you can imagine. I would think our graduates would be able to find some kind of employment. Next question. What previous degrees will be accepted, asks Chris. Well, I think I've already answered that one, but I want to stress that at least from September, with our single pathway programme, we will consider any degree programme. If you have a particular question about that, however, you might have studied something that you feel nervous about, or you might think there's a particular absence or gap or lack of your understanding, then I'm more than happy to talk to you via email after this event, and we can discuss what might work out best for you. Next question comes from Andy. How much data knowledge do I need? You definitely need to know what data is. You don't even need to know what datum means, but data certainly is important. But that doesn't mean that all you're going to do in terms of your teaching and assessment is work with data. There will necessarily be some kind of data analysis. You know, and sometimes it's the more mundane skills which are actually more important. Some programs might aspire you to understand the derivation of a two-tailed t-test or something, but really what would be much more useful is when you get a data set, how do you format it and clean it so that you can put it into a spreadsheet and do something useful with it? That sounds quite basic, but trust me, lots of students seem to go through their entire undergraduate career without actually knowing these sorts of things, these kind of practical ways in which you can handle data. And also, I think it's fair to say that we will be demystifying data. There's nothing special or magical about data, or science for that matter. It's just a piece of evidence. It's a useful tool, and we will train you how to use it accordingly. Okay, next question. Sarah asks, are the modules all new? Yes, they are all new. Some programs, some new programs, are delivered on the basis of you might produce maybe one or two brand new core modules, but then you sample from the existing kind of master's modules that you have, and you can make a kind of coherent program like that. We went for something much, much more ambitious. We did this kind of big bang affair in which all the core modules and one of the optional modules is entirely new. Now, part of that is because we have an ambitious project or plan for growth, the Global Systems Institute. We are hiring in a large number of people from across the university, across different departments. But also, if we are serious about making this a transformational educational experience, then I think we have to start from scratch. And in the future, we may see pathways, different forms of specialisation. But that does mean right now that yes, all the modules are entirely new, and yes, it was a tremendous amount of work, and I most really won't ever do it again. Okay, we are running out of time. I've been prompted. And so we have a last question. What key skills will I learn? That's a good question. That's a really good question. The key skill that I want you to go away with after this program is that you can make a difference. Now, that sounds really woolly, and that's not going to get you a job, but that's why the program exists. Now, it just so happens, if you are going to become an agent of change, then you must have some kind of impact in the real world, because you must be a future manager or a chief executive officer. You must have some kind of leadership position. And that's what I really feel, and I know that's what all the academics who are contributing to this program. If we're going to make a difference, if we're going to affect a difference in the real world through our academic process, then yes, we can research papers and we can do fantastic kind of knowledge generation. But in education, the biggest impact we're going to have is by impacting you, by allowing you to have a transformational education experience. So the skills you're going to learn on the program are working in complex spaces, understanding what systems theory is, being mindful and cognizant that when we talk about climate change, we're not talking about one thing. It's maybe as many different things as there are people involved in it. It's an unbelievably complex system. How do you begin to make solutions in that space? Well, if it was easy, we would have done it by now. Unfortunately, it's going to be your job because it's you and younger generations which are going to have to clean up this mess. So the key skills, I'd say, allowing you, empowering you to become that agent of change, and with that, a flourishing future, which you can make a difference. So I think we're all out of time. Thanks very much for tuning in, logging in. If you have any more questions, then please continue to direct them on the Facebook page, or also find my contact details on the website. And I very much look forward to seeing you in September. Thank you very much.